So we are going to be very careful with the stage. So it says it all, config-driven. Is it boring or not? I hope it's not, because obviously what we are doing today is a bit config-driven. So I'm Nick Pissard, principal engineer here at Glovo. I have, well, long time ago, I managed to get a PhD in computer science, launched my own little company, and then was a data scientist and machine learning engineer at Facebook. I've been at Glovo for a bit more than 1 year, leading and guiding, initiating as well a few ML and data projects. So experimentation, feature store, and MLP and data platform in their declarative way. I'm going to pass the mic to.
And I'm Pablo, been at Glovo for 18 months now. For those who don't know me, I'm in data domains and centers of excellence. Before Glovo, I've been in data for over 10 years. And yeah, in my previous 2 companies, I built 2 different data platforms, both of them config-driven. And that's why I'm giving this one with Nick.
Thank you. So the agenda. A bit too much enthusiasm. Okay. So what is config-driven? You know, it excites me, so that's why I'm enthusiastic. Then we will see the pros and cons for the company and for the individuals, because obviously the interests may not be aligned, if it's not the case here. And the learnings and advice that we had in this adventure of promoting config-driven. So I'm going to start with the first 2 parts, and then Pablo will follow. So what is config-driven? So when you have an engineer that wants to solve a problem, there's many ways of doing in terms of programming languages, but there's also 2 ways, a kind of 2 paradigms around these programming languages and 2 ways to code. So you have the imperative way. In that case, the code describes the steps on how to solve a problem. So you have the different steps that the code needs to follow to solve the problem. And then you have the declarative way that describes the result that you want to see. So obviously it looks better because the system figures out by itself the different steps that it needs to follow. But there's no magic here. It means that somebody else basically wrote the conversion between declarative to imperative, because the way that a computer works, it's imperative. So someone did the heavy lifting for you, and you have a good job of just writing declarative. In the extreme version of declarative, you have config-driven, because declarative can still have like kind of complex syntax. Config-driven is very flat. It's parameters, basically. So in the declarative way, instead of focusing on the how, people can take advantage of all the good work that other people have done and then focus on the what, which is more efficient. So the game of config-driven, when you build a platform, is to basically factorize things, extracting the specific from the generic. So there's a few, I would say, in a few contexts, it makes a lot of sense. In some other contexts, a bit less. But if you have standard patterns, meaning that the ratio, the number of lines of specific versus generic, when it's low, you have very few specific and a lot of generic, tons of boilerplate, basically. In that case, it makes a lot of sense. When you can avoid complexity, meaning that the specific that you have is very simple, meaning that it's just a list of params. And then when the best practices are key, meaning that the quality, I would say, that your generic has to follow is high, and so it's complex. And the fact that there's quality in this generic, it changes the outcome. If you do bad things with very, I would say, performing system, it's not a problem. You insert, it takes 3 milliseconds instead of 1, at the end, nothing changes. But for ML, there's a lot of change in performance depending on the attention to details. And in that case, it's extremely valuable to follow config-driven because you control the quality. So a few examples of declarative, config-driven, and even further, low code and no code. So we all know HTML. So HTML is declarative. You don't say, oh, you display this thing. You just describe what you want to see on your pages. CSS, the same. Jinja is a language of templates. So all the template languages are declarative. They generate HTML in a declarative way. So I'm not going to go through all of them because we don't have the time, but one that is particularly warm to my heart is a SQL. SQL, DBT, amplitude. So these ones, data related, are either config-driven or even further when config-driven is associated to a web UI where by drag and drop you can config your system, it becomes low code or no code. And so it's all the same family of things. So in the data world, we were saying, well, DBT, so data engineering, pipelines are made of tasks that are dependent on each other, and tasks are really highly standardizable, I would say, because it's just a handful of operators and a few parameters. For data science and ML, it's the same. Feature engineering, you have features that depend on other features with very limited set of operators. So in that case, you can standardize it a lot. And ML models are, well, at least at Glovo, very supervised. So classification or regressions, and even pre-processing is always the same, and you always use the same thing. And in that case, it makes sense to do config-driven. Same for data analysis. The different things that you can do with slice and dice, root cause analysis, and experiment scorecard probably cover 80% of the analyst job. So not going to go too far into the coding, but high-level architecture is basically, the goal is to create an abstraction layer between user and the standard tooling. So traditionally, the way that we do without config-driven is to have a notebook that directly interact with all these standard tools. So that for orchestration, key value database, SQL database, a bit of orchestration for data engineering, and then some ML. So that from your notebook, you directly interact with that. But here, for config-driven, you are separating the two by this abstraction layer. And it's what makes the difference, because this abstraction layer decouples the user side and the backend. And in that case, because of the decoupling, the backend becomes non-relevant for the user. The user just cares about the business logic and the way that we manage to get what the user wants, it's on the platform side. And so if we want to change the technology, if we say, oh, Redis is not good enough, we want, I don't know, Cassandra, DynamoDB, okay, we can change it very transparently because the user has always the same abstraction layer. So no more vendor lock-in. We want no AWS, we want GCP. Okay, so we can do it without the user even knowing, and no painful migration for the user. In code, or does it work? Well, it's just a matter of structuring things a bit because we have the same kind of code that reach to the same thing, but in 3 different ways. You have a very tangled code where the generic and the specific is all together in the same code. You have some data scientists that are doing a particularly good job at extracting the config from their code. So they are kind of creating an object, having the config, but still it's very specific. And you have the config one. So it's where it becomes dangerous. So here, everything is generic, and so can be used for many different use cases, except the definition. So the config that you have here is going to be just one row in a database of a config registry. And all the rest is kind of factorized and can be used for all the use cases. So a few desirable qualities of config-driven platform. It must be assisted, meaning that every level of data scientist or data engineer, from the beginner to the most advanced, should find some solutions to their problems. So for beginners, a lot of smart defaults. If you don't know how many CPUs you need, the system can figure out. Okay. You want clear login and error messages because traditionally you have this interpreter that is transforming some very short configuration into something way longer with smart default. So if you cannot control what you're doing, it becomes hard to see if the platform is doing a good job. So it's good to have like good logging. And then it needs to be trustable. When I say trustable, is that you want to build on top of it. You are really sure that your code is your own code. So that's why it's very sure because you know on what you are building. But in the case of config driven, you can build on the code of other people. So you want some kind of safety in doing this. That's why immutability is very important. You want to build on some immutable code, at least in terms of version. The code may evolve, but it has to be explicit that you use the new version of the code. So trustability is extremely important. And then hackability, you want your system be extensible, mainly via what we call inner source, meaning that it's like open source, but inside the company. So people can develop, put their own module that respect the design inside the platform so that it fits their need without the platform team being a bottleneck. So we've begun to see a few advantages of this type of platform, but we are going to see that more in details. So the advantages for the company first, a lot more control. So it's not employees that are shipping tons of code that is of uncertain quality, uncertain places, uncertain compliance with regulation and things like that. Here, because it's more centralized, you can control, monitor, and the governance become easy. Okay. Because of homogeneity as well, because we've kind of controlled the generic, we know that the quality is good, and so we can have quality at scale. In terms of resiliency, we are less dependent on key people leaving the company. Traditionally, when you have a key people leaving the company, it becomes a mess, and the company is taking years to come back to a good situation. Here, because there's a kind of consolidation of the knowledge, it's not happening. And then more impact for less money, because the ramp-up time is lower, so people become efficient more quickly, I would say. And the end user can focus on solving business problems rather than reinventing the wheel. So for the platform builders, it's rewarding work. Today, in the non-config driven world, when you want to help a data scientist, you need to look at their code. And traditionally, it's not great code, it's more scripting. And so in that case, the platform builders, the software engineers that are working on platforms are doing some kind of non-interesting work. So here, they are building something. They are building a product. So they need, the work is more interesting. Also, it solves the things around buy versus build. It's what we saw this morning with AWS around this strategist builder. We don't want to build everything. We just want to build the only little pieces that bring a lot of added value. So no vendor lock-in, outdated tech. Okay, we saw that already because of the abstraction layer. It's iterative, meaning that the teams can build piece by piece and demonstrate value quickly and iterate and optimize later. And then something that the few platform engineers amongst you can understand, the big pain of building test environments. So because you need to understand the different configuration of people that are going to test on their machines, and it's a pain. And so in that case, because we control the execution, it can be done in production directly without being done in local. And then for the user, but the user inside the company, I would say for the employee, it's a smoother learning curve, easier to use because of the smart default, because the specific is very clear. It's easier to iterate and collaborate because obviously when you want to see the changes of your colleagues on a config file, you can very easily spot where the changes were, but in code it's different. And then it kind of pushes for more shared ownership of models. Meaning that today you don't want to go in the model of your friend, of your workmate, because you know it's a mess. It's super tangled, super hard to understand. You're going to have a headache. In the future, because it's just a config file, you can see the different things and you can say, oh, we should change the value of this thing for another thing. And it's just that. You don't need to change any code. You just change parameter values. And then in terms of quality, reusability, standardization, we've already talked about it. You develop a template once of high quality, and then you can use it forever. And reproducibility, mainly based on immutability. You are sure that because you are having the same inputs, you are going to get the same output. And that is quite important, particularly for analytics, when you want to check or you want to rerun the analysis 6 months later. And if everything changes, you can't, but here you can. Well, 3 pages of advantages. So now I need at least one of advantages, I would say. So the main is centralization. Because we are centralizing all the artifacts, I would say, in the same registry, it can go against a certain idea of autonomy of teams. It's not really true because you are building a platform and teams can be autonomous in building their config files, but you are removing a bit of autonomy. And it can be seen as creating bottlenecks as well, even if it's not entirely true because there's inner source. The problem of inner source is that it's harder than scripting, meaning that you can do your own little script that train a model relatively easily. But when you need to conform to the standard of a platform and insert your code at the right place with the right standards, it's harder. So that's why it's a bit of a limit here. For the platform builders, because it's so central, it creates a single point of failure, meaning that if your system breaks, nothing works, okay? And that is, in general, a problem as well. For platform builders that are software engineers, they also need to understand very well the needs of the users. And so basically, they need to be some sort of analyst by themselves. It's what we see today when we develop MLPV2. We are our own client by developing routing models ourselves. So machine learning engineers, software engineers are playing the data scientists to see if the platform is efficient to use by doing the data science job themselves. And that is super hard to do. And for the company, it's more displacing an investment than reducing the investment, because basically you are investing more on the central, a bit less on the domains and the local. And then, yes, the same thing, like say, because software engineers need to understand DS very well, that's profiles that are very hard to find. And so that limits the scaling of this type of teams. Cool, long enough. So Pablo, please.
Cool. Who's convinced so far? One hand. Okay. I have 10 minutes to change the mind of the rest. Nick, you haven't done a great job, man. So I'm going to talk about from the individual perspective, what's in it for me. I'm drawing from previous experience, from having done this in different places, and also from the fact that once we started talking about config-driven and declarative at Glovo, I've seen a lot of fears and concerns and so on, and trying to address some of those. Okay. So talking about the individual perspective, I'm gonna be focusing in 3 pillars. One of them is productivity. Does it impact it? The second one is learning, and that's one of the main fears. Does config-driven mean that I'll stop learning because I'll just use templates? Like I am gonna be the expert on JSON. And the last one is, how about my job satisfaction? Maybe I'm gonna hate my job because I'm gonna do something that is not interesting any longer. Yeah, I've heard about this many times, and I think that I wanted to shed some light. So let's talk about productivity, and the way in which I want to talk about productivity is doing a parallel with the cognitive load model. Yeah, this model tells us that, well, there are 3 types of cognitive load. One of them is the intrinsic load itself, like how complex is what you're doing. Yeah, and creating a new class, like it has some complexity inherent to it. The second type is, let's call it the environment type. So I need to deploy something, I need to run it on a machine, like things that are not about the task itself, but how you use that task to kind of answer something. And the last one is the germane of the business context, which is I need to understand the business in order to resolve the problem. If you separate the two, that doesn't work. theory says that if all of these three are super high, you're gonna be like every time that you get home, you are dead. Your brain power is completely exhausted, and this is kind of recipe for burnout. Yeah, and also impacts productivity because you cannot be running at that level for too long. The opposite is that these three are very low, and this means your job is super boring. Like it's not complex. It doesn't require any mental power. You feel underutilized. And in principle, what we want to achieve is that one of these is high and the other ones are lower, so we don't go all in. And what declarative does, or conflict-driven does, is that it reduces the load on the first two. And obviously, you can decide to invest that load in understanding the business context better, but that doesn't change. Your business context is the same. So essentially, it reduces your cognitive load, and I argue that it actually makes you more productive, seeing it. So that's point one. The second one is learning. For that, I'm going to use kind of parallel to the Maslow pyramid, if you want. But let's say that what we do in any company responds to three main categories. And basically, what we do in tech, first, you address the most basic needs. Yeah. This is what we need for the business to move on. As you operate, and this happens everywhere, you start generating technical debt. And if you have a bit more capacity, you start paying it. And ideally, at the top of the pyramid, like in Maslow's terms, the self-actualization is advanced needs, like projects and so on that we normally don't get to them because we don't go that far. And what happens when capacity changes is that if you are only able to cover the basic needs and not even that, the technical debt is growing faster than you're actually covering the business needs. Everyone is complaining at your work because actually not getting there. I call this a state drowning in misery, and this is where we don't want to be. Okay, learning here is super limited because you're doing something super rushed, probably not being able to spend the time to spend some quality time on it. So you don't want to be there. The second scenario is that capacity that we have is a bit higher. We are able to cover the basic needs. We are able to pay that technical debt. While you do that, you start actually looking at problems from a different way. So this technical debt is not incurred in the future and so on. You start learning a bit more. You have a bit more slack. You might not be remembered for the amazing job that you did and remember that person we had in the company. Probably not, but you're in a fairly stable, comfortable position. That's good. And now, obviously, let's go to the last scenario, which is a scenario 3. So you've actually paid technical debt. You can get into the type of projects that normally we don't have time to. These are projects that require new architecture, new ways of facing things. This is where you really learn. This is where we all love to be, or those who have kind of high ambitious people want to be there, want to be looking at things that no other people have resolved before and so on. So what I'm trying to convince you is that by going conflict-driven, we are going to be increasing our productivity. So it's kind of similar to having more capacity. And we're going to have a lot more chances to get to the last category of advanced needs. Okay. Nick wanted me to also bring a kind of counterpoint to this, which is, okay, but I'm also learning non-transferable skills, like using the platform is going to be useful for being at Glovo, but as soon as I go out, it's useless. That's true. It is also true that we should be making the platform so easy to use that the amount of knowledge that you need to use them, and we are not there today, but the amount of knowledge that you should need for making use of them shouldn't be huge. Yeah. The second thing, and yeah, this I'm going to struggle to say this one, but reinventing the wheel can be cool, for especially when you have someone new joining the team and wanting to kind of do the same thing wrong, so you can teach that person how to do it right and so on. I fully disagree with that, but hey, it's a perspective. Anyway, talking about the learning, my last point is actually about job satisfaction. And before getting there, what we are talking about here is that we are automating the repetitive, which I hope you don't try to convince me that what you want is a repetitive job. So we can explore type of projects and territory that we haven't been there before. Yeah, and this is what we this is the right approach to conflict-driven. I'm not saying it's the only one. Yeah? Let's go to the last one, which about job satisfaction. So I've checked in literature and different models. These are some of the factors that affect job satisfaction for different type of people. Not everyone is driven by the same thing. But for example, environment is the people you're surrounded with, the kind of the interaction that you have. Challenges, learning, we discussed that a second ago. Normally, high achievers want to be learning day after day. Money and perks, well, no need. Flexibility, in which the company lets you work like from home sometimes or from different places, the days that you work, you call it, yeah? That's the type of flexibility. Being recognized for what you do. Like you want to understand that you're contributing to something bigger than yourself, like the mission of the company, and also receiving feedback so you understand that you're moving in the right direction. Variety of the job, of the work that you do. Again, repetitive work, communication, especially top-down communication, that you understand where the company is going, the purpose. So are you helping the world with the company you're in? Again, not everyone is driven by the same. Freedom, as in you can do your job the way you want. Okay, so let's see how conflict-driven actually impacts this. And I would say that there are 3 factors in which conflict-driven impacts. The first one is challenges and learning. Talked about it a second ago, won't get into that again. Variety, same point, the fact of having kind of additional capacity or more productivity allows you to see different type of projects. And the last one is freedom, yeah? And for freedom, we would say, look, but freedom is actually lower when you have conflict-driven. And I will say yes, but it depends. So if you're trying to kind of run or use a capability that already exists, then you have not a lot of freedom. You're going to use what the platform gives you and do your job a lot faster. Okay, so we compromise on freedom there because you're using, like, you are not going through a new path or going somewhere that someone went already there, and we've kind of creating this golden path. But there is also a reality, which is the platform are never going to cover 100% of the needs that we have today. Yeah. And that goes along the fact that the show must go on. So it's not like if it's not in the platform, you cannot do it anymore. So when the platform doesn't cover the needs, you are still going to have the ability to go outside. Yeah. So it kind of impacts freedom, but especially for those use cases that are already into the platform. Okay. I'll ask at the end if you're convinced, not sure now. But we are going to be wrapping up and talking about some learnings that we got from this and a wrap up. So while doing this, there are a few things that we believe that we've learned here and before. First one being start simple. And that's something that we haven't done for all our cases. For example, our first use case for MLPV2 was actually pretty complex and it took us a bit longer. Second one is we believe that inner source is a key enabler. Nick mentioned that earlier, and we really share that. Like it is about giving everyone the ability to go outside of what's prescripted. The last one on the things that we believe we have to do, and one of the reasons why I'm here today is invest in communication. Like we believe that we have been communicating in some of the tools too late, and that has led to excess of fears and kind of imagining how bad it could be when it could be a lot better if we had done a better job at proactively communicating how this impacts to our community. Things that we won't plan to do is that as we have some capabilities, we are only going to look at some use cases. Those use cases are going to be applied or are going to be satisfied with capabilities we have, but the rest, if it's not in the platform, again, we need to continue doing it, and we are not closing the door to that. Inertia, and I think we believe that it would be a lot easier to bring everyone into a new set of tools, and everyone would embrace them and so on. And maybe we discovered that, again, connected to communication, we need to be a lot more proactive. And the last one is that this is when you develop a capability for the first time and it's a platform to developing it, you need to be in very close collaboration with those using it. And sometimes we've done that too late, and that has delayed the project. So strong collaboration between platform and domain teams is an enabler here. And just to complete this one, so what do we get out of this? Key takeaways. What do you get out of this session? So declarative is a way to use abstraction to reduce your repetitive work. Okay, point number one, abstraction to avoid repetition. The second one is that it is an enabler to scale quality. So a good way to have or to get to high quality outputs across the company is through config driven. Yeah, from a company perspective, it maximizes value. And from the employee perspective, we strongly believe that it actually impacts job satisfaction positive. And with that said, who's convinced now? Whoa. All right. Thanks a lot. We will leave it here, and now it's time for questions. I'll repeat the question when decide who answers it. But it's about the new regulation that enforces transparency, especially on AI, and how having a platform like this would help to provide that transparency. So I think that it actually helps us because it abstracts a lot of the boilerplate code, and there is no the fact that we always use as a templated algorithm to get to a solution helps us in explainability as well, versus if we have, for every different model, we have a different way of doing it. It will take us a lot longer to figure out, in this particular case, how it has been implemented so we can explain it to the outside. So, for example, for, say, the way in which we implement LightJVM, which is one of the first templates. Anything that we need to explain now is a lot easier because we understand where the features are coming from. We understand how that is templated and implemented, and it's slightly easier to explain. And explaining ML and AI is never easy, but it gives us a bit of support there.
Yeah, I believe the standardization of algorithms of the utilization of the algorithm will help a lot in kind of not repeating this difficult work that is explainability around algorithms. Also, on the feature engineering side, I think it's very important that we see that the features being centralized, you have a tight control of where it comes from. For example, in the feature store, because you're having dependencies on features, it's a lineage at the column level, and that GDPR loves because you can see with the root features where the features goes, basically everywhere. And that is a way to tighten the control around privacy information, for example. And so in my previous company at Facebook, there was a huge push for using feature stores just because of that. Not because it's easier, not because we are more efficient, but just because lawyers were pushing us because we didn't want any leak or any problems with PII. Any other question? Yeah, so, So we were talking about risk and the fact that config-driven is reducing the risk for churning, for example, the fact that if a key person leaves the company and they have like key models, it's a huge pain to reappropriate the model so that you can iterate again. And so it takes a lot of time to do it. And the question was about the fact that inner sourcing, we are just displacing this problem within the platform, because if a key person have developed something inner sourced within the platform, we are having the same problem. Yeah, that's true. The only thing is, because it's cleaner in general, so because inside the inner source, the standards of development and software engineering should be higher. And so it should be more software engineering coding rather than data science coding. And in that case, the code is probably more renewable and maintainable than something that is more a script of a data scientist. So I don't want to generalize too much, but the maintainability of systems done by software engineers are supposed to be a bit better.
Thank you so much, Nick and Pablo.